Hey, this is Dr. B, and let's take a look at net ionic equations from the point of view of electrolytes. The big point we're going to make is that if it's an electrolyte, you include it in a net ionic equation, but only if it's strong. If it's weak or non, we write it as it's a non-dissociated counterpart, as we should, since that's what's actually in solution. Electrolytes can be either cations or anions. They can be strong, weak, or non. Imagine the dissociation of sodium chloride. Being a group 1 ion, it's going to dissociate completely into the sodium cation and the chloride anion as soon as we throw it into water. So that's what's actually in solution. Completely dissociated. Acetic acid, not so much. With a Ka of 10 to the minus fifth, most of it stays undissociated. That's why it's a weak acid. We also can call it a weak electrolyte. Sugars, on the other hand, like sucrose here, will dissolve completely, and yet nothing falls apart. There's no ions that form. Therefore, it's a non-electrolyte. So strong electrolytes can include the strong acids like hydrochloric, nitric, perchloric, sulfuric, as well as some of the strong bases like sodium hydroxide. The weak ones are those ones that only dissociate less than 1 part per thousand, like acetic acid, hydrofluoric, nitrous acid, ammonia. Water's even, 1 part in 10 million, so even less. Non-electrolytes dissolve but don't dissociate at all. Things like the alcohols, methanol, up to the C3 alcohols. The other ones don't dissolve in water, right? Sugars, things like that. So tell me, is it strong, weak, or non? Perchloric, strong. A sugar, this looks like sucrose, non. Nitric acid, strong. HF, weak. Ammonia, weak. Water, very weak. Sodium hydroxide, strong. Methanol, non. Acetic acid, weak. Sulfuric, very strong, at least the first association. Hydrochloric acid, strong. Another sugar, non. Nitrous, weak. I hope you get the idea. A couple of notes. The double replacement reactions always require a precipitate. If you're going to mix things, you better get something that pops out of solution. Otherwise, you're just simply making ion soup. Nothing has come back together. Anions and cations are always shown independently in a net ionic equation, but it's a bit of an illusion since they cannot be placed in a bottle. They can only exist when they're counterpart together. And if you really think about it, a net ionic equation shows what actually occurs in solution. We keep the weak and the non-electrolytes together because that's how they exist. There are some ions that are always soluble. The ones that you really should know are by memorizing SPAN. It's S for sodium, P for potassium, A for ammonium, and N for nitrate. If you have those ions, it's always soluble. And when writing net ionic equations, only ionize those strong electrolytes. This is an introduction to net ionic equation from the point of view of electrolytes.